Hi guys, you should have this page opened up in your packet. Today we are talking about altitudes, medians, and bisectors, and geometric mean we're going to leave for a little bit later on. So let's start off with a triangle angle bisector theorem. You all should know what an angle bisector is. Remember, it just cuts an angle directly in half. So here it states that an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides. Okay, so what that means here is that my side AD, the bottom part of the triangle ABD, is going to be proportional to this bottom part of triangle DBC. And we're going to set that equal to my other sides. So in triangle ABD, it's this side here, AB. And in triangle DBC is that side, BC. Notice how I did not use the angle bisector because it says that it's proportional to the lengths of the other two sides, not the one of the sides in the angle bisector. Okay. So that's the triangle angle bisector theorem. We also have some stuff about altitudes. So if two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. So when I have an altitude, remember that means that it's connecting a vertex to the opposite side, but it's doing so at a right angle, or it forms like a perpendicular. So, so what we know from this is that the corresponding parts are also proportional to the corresponding sides. So in this case, I am going to be using the altitude. So BD and FH are my altitudes here, and they're proportional to corresponding sides. So BD and FH should be proportional to any of the corresponding sides in my triangles. So for example, AB and EF. There we go. We could have also said BD over FH is equal to FG over BC. Or I'm sorry, the other way around, BC over FG. As long as it's one side of the triangles that are corresponding. So let's look at the angle bisectors. If two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. Remember, an angle bisector connects, or it splits a angle right in half. So let's look at our proportion here. QS, the angle bisector, I am using it in this case. QS and UW are my angle bisectors, and they should be proportional to any other pair of corresponding sides. So in this case, I just chose QP and UT. I could have chosen something else like PS and TW. I could have chose SR and WV, as long as they are corresponding. So let's finish this off with my medians. Remember, a median connects a vertex and the midpoint of its opposite side. So in this case, HJ and LN are the medians. So for the medians, if two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. So in this case, we have our medians, and they are still proportional to any pair of corresponding sides. So HJ and LN are proportional to any other parts of the triangle, as long as they're corresponding. And in this case, I just chose GH and KL. I could have chose KN, or I'm sorry, GJ to go on top and then KN to go on bottom. I also could have chose HI and LM. As long as they are corresponding, it doesn't matter. So let's go on down to some practice problems. And number one, I will do for you. So let's see here. It says that my two triangles are similar, so that's good. And then on top of that, we know that we have this here, which looks to be my angle bisector, and we have an angle bisector over here. So I'm going to use those two. I'll do the big triangle on top and the small triangle on the bottom. And so I use the other side that they gave us, which in this case would be AC, and it goes directly across from the 32 because it's part of the big triangle on top, small triangle on bottom. And then the other side that we didn't use would be this X, which we don't know what it is. So let's cross multiply and figure that out. When you do so, you get X is equal to 28.5. Okay. And if you plug that back in, you will see that that it is proportional. So go ahead and try number 2, 3, and 4. Pause the video, and when you are ready, unpause it, and I will have the answers put up. Okay, there is your answer to number 2 and number 3. So number 2 actually should have equaled 33.6, and then number 3 should have equaled 17. So I just wanted to go through number 4 really quick. Notice that it says KM is a bisector, so that's good to know. My triangles should be similar at this point. So when I'm going through, I'm going to start setting this up, and I should have set up 27 over 18, because this is the bottom part of my triangle JKM, and 18, if you subtract 27 from 45, you get 18 here, and that's the bottom part of my other triangle MKL. So I have 27 over 18 equal to this 3x minus 9 over, what is it, x plus 11? Okay, so even before I cross multiply and solve, I could have done this in number 3, but I thought I would give you guys a little tip and trick. If you would like to start reducing this before you even cross multiply, it may become easier for you. So I noticed, since it's proportional, since the two triangles are proportional, I can go ahead and reduce that first fraction, and I'll end up getting the same answer. So if I reduce 27 over 18, I know that 9 divides into both of them, so that should be the same as 3 halves. And I'll still set the equal to 3x minus 9 over x plus 11. So if I cross multiply and solve, I'll have 3x plus 33 equal to 6x minus 18. Subtract 3x from both sides, I will get 3x equal to, if I add 18 to both sides, I get, what is that, 51, I believe, yes. Divide by 3, you still get x equals 17, and if you solved it by using the larger numbers, you still get that same answer, x equals 17. So it's just a little tip and trick to help you solve it quicker, and you can also do it more mentally than having to break out the calculator. So that is your tip and trick. On the back here, I'd like you to just finish this off. So draw a diagonal on the rectangle to form 2 right triangles. In one triangle, you're drawing the altitude. Number all of the angles that you created, and how can you match the angles of the triangle to show that all the 3 triangles are similar? So you're just matching congruent angles. So go ahead and give that a try, finish that up, and bring it in next class.